So guys, welcome back to a new video. So let me change my view. Okay. So today we are going to solve this question. So if you are new to the channel and if you haven't subscribed yet, please consider subscribing. I have solved all these much of questions. You can see all these are covered, and today we are going to solve this. You can go to my channel and click on subscribe. So yeah, you will get the notification. Also turn on the notification. Yeah, I have created a playlist. You can definitely check out that and follow along all these questions with me. So yeah, let me come to the question. I already opened it. So sliding window maximum problem. So it's a hard problem. You are given an array of integers. There is a sliding window of k which is moving from very left of the array to the very right, and you can see only k numbers in the window. Each time sliding moves right by one position, so we have to move the window by one position at a time. Yeah, and so basically we here I let's suppose there is a window of size 3. So this is the first window and the max is 3. So the we will append one here corresponding to this. Now the second window is like this, of size 3 is this. So here max is 3, so we will append 3. So here everything is like given us to how it is calculated. So basically we have to calculate the max of this window for every window in this array. So this is tagged as a hard problem, but this is not a kind of hard problem. You can say it's a medium problem. Yep. So I have already drawn the necessary things. Let's see the approach first. So yeah, this is the code, but let us see how this code gonna work in this whiteboard. So yeah, so this is a queue, a doubly queue or a deque, which have like the front and back. So we can add at front and we can pop at front, we can add at back and we can pop at back. So this is the feature of deque basically. So yep, so we will start with the index 0. So these are the index, these are elements, and the size of the window is 3. So we will start at this window k equals to, so I equals to 0. So you can see this for loop runs I equals to 0 to n. That will yeah. Before that we will decrease the size of this window. So since we are dealing with the indexes that start from 0, so we also decrease the k for the sake of simplicity. Otherwise we have to deal the here values here. So I just for the simplicity I decrease the k value so that it will easy to see and understand how the things are working here. So yeah, see this for loop start with I equals to 0. The value at the I0 is 1. So here the num is, so since the queue is empty, we will not at the very first position we will not go into this loop while loop. We'll simply push back this into this queue. So let me just push back this value here. Yeah, I will write the index. So we are, since we need to maintain this window and we need to deal with the indexes, we will store the index instead of the value. So yeah, we will store the index 0 here. Yeah, and then we will check if this I is greater than equals to k. That means we have like reached the necessary window size. Then we will push back the first element at the front in the queue. So we have not yet reached the window size. So we have just we did the first element inside this window, which will be of line 3. So yep, we will not this will not run. And also the queue front is smaller than I is minus k. So this condition, so let's see, I equals to 0 and k is like we have 2. So we decrease this. So 0 minus 2 is not greater than the front is 0. So yeah, minus value is not greater than this 0. So yeah, this will not run. So we will go to the next I, that is this. So let me move this. We will move to this 3 and we will pop. So this while loop run, it will what basically do is will pop out all the element from back where the value corresponding to this index is smaller than the current value. So value is 3 and the value against this 0 is 1. So we will pop out this. So we will simply just remove this. Let me increase this side. So let's remove this. That means we have popped it out. Then what we will do is we will push this I the index here. So this is 1, and then we will check again. So the I is not greater than k is 2, I is 1, so it is not greater than, so this will not run. And also this is 1 and k is 2, so 1 minus, so it is also negative, so again it will not get uh, pop from the front. So we will move the window to the next value, that is -1. So again the value is -1, but the value against this one is 3. So this will not pop out any element. Instead it will push the -1 here, the index 2 here. So let me push the index here. Okay, now the so let me write a answer array also here. So the first element we will push it here. Since k is become I, that is 2. So I is 2 and k is also 2. So we will reach our first window, that is this window. You can see. So this window is of length 3 and the max here is 3. So that is why this is the condition reached, and the push, we will push back the q front. So what is the value of the front? That is at index 1, that is 3. So we will push back to this answer. And then yeah, so now we will check this condition. So this is q dot front is smaller than or equals to I minus k. So I is 2, k is also 2, so 2 minus 2 is 0. Front is 1. We can see this is front is 1. 1 is smaller than or equals to 0. No. So this will not run. So we will, this condition will not run. So we will move to the next value. Let me just, okay. Next value is this, that is 3. Index is 3 and value is -3. Same we will check here while the current value corresponding not, so this will not run because the current value is -3 and -1 is bigger than this. So yep, and we will push back here. So let me just push back to this here, 3 here, and we will check if I is greater than, yep, it is greater than, I is greater than k. So I is 3 and k is 2. So yeah, it is greater than, and we will push back the first, so that is 3. So let me just write here 3. Yep, so this value against this one is 3. So yeah, so we will similarly check here I, that is 3 minus 2 is 1 and front is 1. So yep, we will uh, pop out this value from here. So let me pop out this. So the front is 1 and I minus I is, we have 3, 3 minus 1 is, so 1 is smaller than equals to 1. So yeah, we will pop out this. So let me just, yep. So similarly you can run this till end. You will see, you will find this array which will be like this. So yeah, that's, you will see this. So let me just quickly write the code here. So let me just, yeah, so here we will need this n equals to nums of size, and then we will decrease the k as I told you, and we will need a deque. So let me write this deque here, we will name it q. So we will run our loop from the very starting to the this end. So let me write this. So we will run the while loop while not empty q is not empty, and the element, current element at that I is greater than and equal to q dot front. nums of q dot not front back. Yep. So we will pop out q dot pop back. So yep, and then we will just put our current value inside q. Okay. So yep, and then we will check for the condition. If I is greater than equals to k, then we will update our answer. So let me write this. I'm sorry, vector equals to answer. Okay, answer dot push back this q dot front value. That will be our max in a window. Yep, and then we will also check for the current we are removing the current element from the, so the element just before the window, so we will moving our window, so we have to move pop out the first element or the element just before the window. So for that we will check if whatever at the queue front is greater is greater than equals to uh, I minus k. If it's so, so we will pop out front. Yep, and we will return answer. So yep, I guess this should work. Let me check once. No, this should. Okay, let me just make this. Okay, this is giving wrong, so let me check again. So as we decided, we started from this value and we are updating this uh, answer, and we are pushing at the back and seeking our uh, answer at the front. So thus we are doing here, so this should be smaller than equals to, I guess. Yep. So let me just submit it and check if it works for other cases or not. Yep, it's working for all the cases. Let's check the time complexity here. So this is for loop is running for n, and this while loops run for one element only one time. It is eliminating the element once it is go through that. So it will not be increase the time complexity for this for loop. So it will not considered as O of n or something. It will be inside this. So yeah, uh, so the overall complexity will be O of n. Let me write here, and space wise we are using this. So at max all the element inside this given vector will be inside this. So the space complexity at max can go this O of n. Yep, so that's about this video. If you like the video, click on the like button and also consider subscribing. And let me just tick mark this here, and tomorrow we will start with stack problems. So yeah, definitely consider subscribing, and I will see you in the next video.